Okay, so today we're going to do lesson 4. So hopefully you had a chance to read it and do the vocab. And a lot of this stuff we already did in JavaScript. So for the freshmen, this should be pretty easy. So as a reminder, the equal sign is called the assignment operator. It's used to assign a value to a variable. So for example, if I have the statement int I equals 3, I know in memory, I reserve an integer location that will called I, and in there I store a 3. Notice that we always put the variable on the left of the equal sign. So variable on the left and the value on the right. So this is the variable we're changing, especially when we declare something. Okay, now if I try to flip it around and say 3 equals I, this isn't going to work because the variable's not on the left. Suppose, though, we created another variable called j, and then I made a statement, j equals I. So that is like saying, let j equal the current value of I. So what Java would do is go to memory, figure out what I equals, and then assign it to the value of j. So one cool thing that you can do in Java is that you can make multiple declarations. So it is legal to declare and or assign several of the same variables of the same type on the same line. Just separate them with commas. So for example, I can make a statement like this: int x comma y comma z equals to 5. So in memory, Java reserves a location for an integer, assigns it a variable x. It reserves another location to store another integer, and y points to that location. And in the third example, Java reserves a location to store another int that it will refer to as z, but in that location, we put a 5. Only z gets the 5 in it. I can do the same thing with doubles. And in fact, I can actually do little calculations as well when we use an assignment statement. So this says double k equals 3.4. Notice a larger memory location stores a double. K points to that location, and we're storing 3.4. M is equal to z plus k. So Java goes to memory and says 5 plus the value stored at k, 3.4, so that equals 8.4. So that's why 8.4 is stored in memory. And finally, n is equal to 2 times k. So Java grabs the 3.4, plugs it in here. 2 times 3.4 is 6.8. So n is pointing to a location that stores that variable. So as we have discussed in Java, you can use all the basic math operators: addition, subtraction, multiplication, and division. But there's a new one called modulus, and that symbol that we're using is the % symbol. So when you see that symbol, percentage, you think modulus, or sometimes it is referred to as the remainder operator. It just depends on what book you're using about Java. So the format is going to be A remainder B. So A, the answers always will be, whatever the remainder is, it'll always be the same sign as A. And it doesn't matter really what the sign of B is. So we're going to look at a few examples. So if I say 9 remainder 4, let's come down here. So I'm taking 9, dividing it by 4. 4 goes into 9 2 times. And then when I subtract 8 from 9, I get a 1. So the answer is 1 because that's what the remainder operator is doing for us. I can say 0 remainder 4. So that's like saying I want to figure out how many times does 4 go into 0. 4 goes into 0 0 times. 0 times 4 equals 0. And when I subtract 0 from 0, the remainder is 0. So that's why that's equal to 0. If I tried something like this, 9 remainder 0, what I'm trying to do is to take 9 divided by 0. But we know we can't do that. That's mathematically incorrect. So we say that's undefined, and that's why I marked that one not allowed. So notice from above we said that whatever the sign of A is, our answer will be the same sign. So notice I have this same problem. The only difference is that the A is negative, so our answer becomes negative. Same over here. Notice in this third example, 9 remainder negative 4, the answer is positive. So look back on those examples, and we're going to do those in the demo just to convince you. So in Java, we follow PEMDAS. And the order of precedence is always going to be do parentheses first, followed by exponents. MD stand for multiplication division, but we're also going to throw in the other M, modulus, since that's a new math operator. And then finally, AS is also addition and subtraction. Now, one of the things we have to watch out for when we're doing math in Java is something called integer math. So if calculations involve only integers, the answers are truncated, not rounded. So for example, remember this stands for system out print line or print. If I have this operation where I have a string and I'm concatenating it with 5 divided by 2, this part is a math calculation. So Java performs this as a math operation since there are no strings. Also note, whenever I have a string, which I do, concatenated with a number, all this does is create a bigger string. So let's go through the math operation. So in Java, 5 divided by 2 is 2. It's actually 2.5, but because we truncate, that's why the answer is 2. So when we see this output, the exact output for this statement is going to be 5 divided by 2 equals that string concatenated with this answer, which is 2. If any part of a math calculation involves a decimal, the entire answer becomes decimal. So let's take a look using that same example that we just looked at. So if I change and say 5.0 divided by 2, now the decimal is preserved because the answer has been turned into a decimal. So the output will be 2.5. The next example, if I take 5 divided by 2.0, again, any part of the calculation is decimal, the answer will be decimal. If both numbers used or all the number used are decimal, the answer will be decimal as well. Here's a little tricky one. Notice that if I take 1,999 divided by 2,000, we know that's a decimal that's really close to 1, but because this is integer math, the answer is 0. If I do the same problem again, but then multiply the answer by 1.0, this answer will be 0.99999. We'll check these things in Java as well when we do our demo. In the lesson, you also learned about some shortcut operators. So x plus plus and x minus minus. So x plus plus is called the increment operator. It'll increment this variable x by 1, and it increments it after it's used. And then x minus minus is called the decrement operator, and that will decrement after it's used in a statement. And I promised to demo that when we're in class. Finally, just a quick refresher how variables are modified in a calculation. So suppose I have a variable int count equals 15. So here I show you a memory location storing 15 initially. But then in the next statement, we say count equals count plus 3. So what Java does is it goes to memory, it grabs the current value of 15, it plugs it in here, we add 3 to it, so we get 18, and then we store it back in the location for count. And that's why it's showing you that the X goes through 15. All right, so I hope that helps. And tomorrow I will do a demo for you. Have a good night. Thank you.